so this is notes number 2. Oh, it just keeps reconnecting. I'm sorry. I'll give it this one last chance. Can you see me?
I can't see what you're sharing. And then you're gone.
Oh, okay.
Oh, no, it says yeah, you're good now.
I'm okay. Okay. All right, notes number 2, characteristics of exponential functions. Jamal.
I'll wait. Exactly.
All right, so we were introduced yesterday to A and B to the x minus h plus k. Up here in the exponent, this h, if anything added or subtracted to the x, it's going to shift it to the left and the right, and it's opposite of what you think it should be. So plus is actually going to lead you to the left, and minus is going to lead you to the right. Can you see me?
Mm-hmm.
On the back end, any number added or subtracted back here is going to bring the graph up or down and this value is also our asymptote. There's always an asymptote for these graphs, so if there's not a number at the end, it'll be 0. So I'd like to graph a couple of these with you. Just to remind you kind of how it works. Alright, so we'll start with 2 points. We're going to use 0, comma, our A value, and 1, comma, our A times B value. So there's always going to be a base because there's always going to be an exponent. So B is always going to be a number that you will see. A, though, you may have to use a 1 if there is not a number in front of your base. And that will happen a couple of times in today's practice, so I just wanted you to know that. So we'll use 0, comma, the 1, and 1, comma, I'll multiply A and B together. So 1 times 2 is 2. So we're going to actually kind of sketch a graph on our paper. And I'm going to put those first 2 dots on there. We're going to start at 0, 1, and 1, 2. But to those points, I need to apply any transformations that are occurring on the function. So the only transformation that I see is this -3 with the x. Since it's with x, that tells me it's going to go along the x-axis, either left or right. -3 is actually going to go to the right 3. You would think left because it's negative, but it does the opposite. So we're going to go right 3 for each of those dots. So I'm going to go 1, 2, 3 to the right for that one, and 1, 2, 3 to the right for the other. Now the next thing I need is my asymptote. And there is always an asymptote. And it'll be y equals the number added or subtracted on the back end here. Well, we don't have a number added or subtracted on the back end, but we can use 0 for ours since there is not a number. So we'll have this boundary line going through the y-axis at 0. It's basically the x-axis. And now you should be able to sketch your graph. So graphs go from left to right, so it's going to rise through both of those points and come down and close to the asymptote on the opposite side. Delta math really helps with the shape of the graph. As long as you put the points and the asymptote on there, it graphs it for you. So the new information that I want to discuss with you today, I'm just going to kind of add on to the idea of this graph, and we're going to discuss the domain and the range. Domain refers to the x values and basically says how far left and right does the graph go. Well, an exponential function is going to go forever to the left and forever to the right. So we'll use negative infinity, comma, positive infinity every single time. I'm going to take this always off of here because it's not always y equals 0. There we go. Now, for your range, the range represents the y values, or how far down and up the graph goes. Well, our range is going to be restricted by the asymptote. So it's going to go from the asymptote number to positive infinity. So just to show you, the range for this particular graph is going to be 0 to positive infinity, because our asymptote was at 0 and the graph continues to go up, 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 up forever. The range would only change to be negative infinity first if the graph was reflected across the x-axis. We're not going to look at any reflections, so it's always going to be number, comma, infinity. All right, I'd like to show you one more. So we will start this graph again at 0, comma a and 1, comma a times b. Your a is 4 and your base with your exponent is 1/2. So we'll plot 0, comma 4. And 1, comma, so we're going to multiply a and b together. 4 times 1/2 is 2. Or 4 divided by 2, 4 cut in half is 2. So I'll plot those points, 0, 4. And 1, 2. To those points, we need to apply any transformations. There's nothing next to x leading us left or right, but we do have this -5 that's going to bring us down 5. So So to each of those points, I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I also need to plot the asymptote. Which is y equals this last number back here. So 1, 2, 3, 4, 5. Sorry, it's a little crooked. And then you can connect the dots. So I go from left to right, and it's low on this side and high on this side. And we'll go ahead and describe the domain and range. The domain is always going to be negative infinity, comma, positive infinity. Your range or y values start at that boundary line because it's going through the y-axis at -5. And then it goes up from there to positive infinity.